Refrigeration and air conditioning part 3. Refrigeration system. Today my topic is to discuss about the refrigeration system and its component and how does the system work. Before that, we'll have a quick look on previous sessions. Right. In a refrigeration system, there are four main components: compressor, a condenser, and expansion valve, and the evaporator. Compressor is where that it doing the work done to elevate the pressure of the gas, and the condenser where it remove the heat from the gas, and the expansion valve it make the pressure difference for the liquid, because after the condenser the gas become liquid and it creates low pressure region, so this liquid starts easy to evaporate, because as the pressure drops it will start to evaporate at lower temperature. And then this vapor enters to the evaporator. In the evaporator, that heat transfer takes place from the space or the area that you have to cool down, and then all the liquid will get evaporated into gas and return back to the compressor. So this is the basic cycle, and we can see there is a TS diagram: temperature against the entropy. Entropy means that is measurement of the level of the disorderness of the substances. So if the gas, let's say in 1 to 2, there will be isentropic compression, which means the matter will not change its phase. From 2 to 3, it is cooling down in the condenser to when it starts to lower the temperature, because in the condenser there will be cooling down, so the temperature reduces, so the superheated gas starts falling down, and at this point, at the saturated gas line, from beyond this point to left, it starts to change its phase from gas to liquid. Okay, from here to here sensible heat involves, and from here to here latent heat involves. And okay, at latent heat there won't be any temperature variation, so the temperature will not vary, only the phase change takes place. And then once all the liquid all the gas change to liquid, then from 3 to 4, that is the expansion valve. So the pressure drops. As the pressure drops, the refrigerant starts to flashing off. Flashing off means the phase change takes place, so that's why this graph moves to this right side from this original position. And there will be reduction in the refrigerant effect, because this is the phase, the boiling temperature at this pressure, that we are in the evaporator heat transfer takes place. So in the evaporator heat transfer takes place, only the latent heat is involved, so the temperature one comes up. The fourth one is in the evaporator, right? So 1 to 2 is isentropic, 2 to 3 is isobaric, because condenser we do not want to lose the pressure, as I explained in the previous videos, and 3 to 4 is isenthalpic pressure reduction in the expansion valve. We do not want to have any enthalpy reduction in expansion valve. And 4 to 1 is again isobaric evaporation, right? So this is the process of the basic process. Let's move ahead with the system. This figure illustrates the layout of a common refrigeration system, which maintain 3 different rooms with 3 different temperatures. It consists of 3 rooms. Let's say a meat room where you have to maintain a temperature of -18, and a vegetable room where you have to maintain let's say 4 to 5 degrees, and finally a handling room. Let's say you have to maintain 5 to 10 degrees. So these are the temperatures that you have to maintain. Let's see what it has. In each room, it has evaporator coil, a fan, and a defrosting heating element. This one is defrosting heating element. Defrosting heating element. And then it consists of, each compartment consists of a thermostat, T1, T2, T3. That is a temperature switch which gives feed the signal. Let's say that if you have to maintain this room temperature at -18, so the compressor or the system has to maintain the temperature, let's say between minus 16 to minus 20. So the average minus 18 will maintain. So the system should cut in when the temperature elevated up to minus 16, and it should cut out when the temperature lowered to minus 20. And let's see what other components. So each room, it has a set of valve blocks. Inlet side, it consists of a manual isolation valve, and then a solenoid valve and expansion valve. First one is solenoid valve, second one is a solenoid valve. So the first one is isolation valve, manual valve, and the second one is a solenoid valve, third one is an expansion valve, and the return side also you have isolation valve. Purpose of these two isolation valve is to carry out any maintenance within this between this space. So if you want to replace any valve or the evaporator repair or fan repair or something, then you have to shut down these two valves. And this solenoid valve, that is starting or opening or closing according to the signal given by your refrigeration control system. This control system, it's a control board or motherboard or control system, PLC control system, that will initiate the command to start or open or close the solenoid valve depending on your cut in and cut out temperature sensing values, right? And the expansion valve, the purpose of the expansion valve, we know already, it is to maintain, it acts as the variable orifice depending on the temperature at the evaporator outlet, it varies the flow. So it sends the evaporator outlet temperature through this bulb and its sensing line, and it added the flow. So the pressure drops will be takes place, and hence the boiling temperature will lower, right? And you have to notice a specialty between these three rooms. There are two additional valves fitted at the higher temperature rooms. This valve, we call it as back pressure valves. These are only fitted at the higher temperature rooms. The reason that is the gentleman, right? Okay, we will come to the reasons bit later. First, we'll discuss how that the system operates. And then this side, okay, this is maybe containing the machinery space or your engine room, and it has a motor with the compressor. So this compressor unit, it receives the gas from the evaporator of the suction line, and then the compressed gas is discharged through the discharge line. Then this gas is processed to oil separator, because during compression there will be some oil mixed into the gas. This oil will return after the separation through a separate line. There will be separate fitting for this one, a float type or maybe solenoid operated type, or the orifice type to continuous flow back into the sump. And then the oil free gas will enter into the condenser. In the condenser, there will be cooling process takes place, and the liquid will collect in the reservoir. This liquid then pass through a filter dryer. The purpose of the filter dryer is to remove any fine particles, the foreign matters from the gas, as well as drying out to make it free from moisture. So there are two main purposes of the filter dryer. It consists with a removable element also. And in case you have to carry out any maintenance, it provides with the bypass line. You can isolate the filter dryer, you can open it up, and that you can remove or replace the filter insert. And also charging connection mostly connected to the filter dryer. So if you introduce any foreign gas, so it ensures that it is moist free as well as any particle free. Then there is a liquid side glass, which here to indicates that the system is runs with the liquid, because at this point we do not want to have any vapor or any air, that we want to have only pure liquid. So if the system has sufficient gas as well as if it is without any air, then this liquid side glass shows actually it should fully fill with the liquid. There won't be any bubble. And then this liquid will enter each room separately. But now let's see how it happens. For an example, first starts with the meat room. Let's say if the meat room temperature, the cut-in temperature reached at minus 16. So then the T1 temperature switch will send the signal to the ref control system. Simultaneously, one thing also happening, that which means as the room temperature increases, evaporator outlet temperature also increases, causing the gas inside this bulb to expand and opening up the expansion valve. So if it's reached to minus 16, which means the, let's say your expansion valve is almost fully open situation, but still there won't be any gas flow because that this solenoid is kept shut by the refrigeration control system in its last cycle. As the room was reached is minus 20, so then the refrigerant control system will shut down this solenoid valve. Right now, as it's reached in minus 16, the refer control system receives that signal, so then it enables this solenoid valve. As the expansion valve already open because of the temperature rise in the raise in the room, then the manual valves also kept open normally. So then that gas will, the liquid will start to, or the vapor will start to enter to the evaporator and cooling down takes place. Fan runs, the colder air will flow through the room and the temperature of the room gradually starts to decreasing, and the return side gas will pass back to the compressor. From the compressor, it receives in the crankcase. There's a special purpose why the suction is led to the crankcase, because there won't be any tendency that the liquid particles get entered into the piston area. So whatever the heavy liquid or droplets will fall down, any oil or moisture, whatever the things or any foreign matter will fall into the sump, and the gas will again pass to the piston suction side, the top of the piston, here through the air gap of the motor, electrical motor. Why it is, let's say it is a kind of superheating theory, or it serves two purposes: cooling down the motor, because electrical motor it produces heat, so by sending this refrigerant it will cool down the motor, as well as this heat will take by the gas, so the gas will get superheated. If there is any vapor particles still tends to enter to the compressor side, these will be get evaporated into gas and it acts as a protection barrier. Then this gas is compressed and the cycle continues. Right. The solenoid operation is quite clear. And one more thing that it happened the same time. Let's say as soon as this solenoid valve opens, as the refrigerant starts to flow, what happens? The suction pressure start to increase because still the compressor in off position from its previous cycle. Right. As gradually, you see, once this open, the suction pressure start all of a sudden. So then the LP cut out, the pressure switch will activate, so the compressor will start to run. As the compressor starts to run, what happens? The suction pressure get lower. The same time as the room is getting reached its upper cutting level, the temperature. That time what happened, because of the sensing, as this line getting colder, cooler and cooler, then this expansion in this gas or the liquid or the sensing in the sensing bulb will reduce, and the expansion valve will gradually shutting down, so closing, right? As the expansion valve closes up, so the suction pressure start to fall down. Simultaneously the temperature will start to reach its cutout pressure. So as the temperature T1 switch gives the control system, it will shut down the solenoid. It will shut down the solenoid. Once the solenoid shut down, there won't be any gas flow through the expansion valve. Whatever the gas remain, it will sucked by the compressor, so the suction line pressure get drops, and the LP cutout will reach its cutout position, low pressure setting, and the compressor will stop, and it wait for the next cycle operation. Maybe one of this room may cause the compressors to start, so it has to wait again. There is a suction pressure increment because of one of these any room, or maybe all of these rooms, the temperature comes reach it their respective cutting temperature. So this is the basic operation of the refrigeration system. So the control system receives the LP system, the low pressure cutout signal, that is manual automatic resetting device, which responsible to start and stopping of the compressor. HP cutout, that is for the safety, which means any high pressure creating the compressor, it has to protect the component as well as it has to protect the compressor. So in any high pressure situation, the HP cutout activated and the system will send the stop signal to the compressor. An alarm will produce. So, and it is not an automatic reset. You have to go there and visually check the plant or the system, because the high pressure means it is cannot be acceptable. So the operator must go there and physically he has to visit the plant and observe any, if there is anything wrong to cause this alarm. Maybe insufficient cooling of air in the condenser, or maybe any moisture ingress, any air ingress, or some other reason, maybe malfunction of HP cutout or whatever. First you have to reset it manually, and before resetting it, that you have to identify the actual cause which create this HP cutout to trigger. And once you solve the problem, then only you have to reset it. And there is another signal comes safety device, that is oil pressure switch. Of course, this is a reciprocating compressor, so you have to have oil to lubricate the rotating and reciprocating components, moving components. So internally there is a built-in the pump, that there should be some way to monitor that pump pressure. So this is the device, the oil pressure switch. Actually it has to, it will not enough to monitor the pump discharge pressure, because as we know, this suction line, the return line, is directly exposed to the sun. So if the suction pressure goes above the start to rise or lower because of this any temperature variation and expansion valve opening and closing, so the sump, inside the sump, the pressure also start varies. As the sump pressure varies, the pump pressure also get affected. So you cannot simply stand alone take a measurement of the pump discharge pressure to get some idea about the oil pump pressure. I will be explain this one in the next video. So how does this oil pressure switch operate? So basically the oil pressure switch is provide as a safety, that it ensures sufficient oil pressure building up in the attached pump, so the components are positively lubricated, right? So this is the basic refrigeration control system, gentlemen. So I think I'll stop this discussion today, and on next time I am planning to discuss about the specific okay, what is this expansion valve, and each component will have look what are these each component, especially the expansion valve and the back pressure valve, what is their purpose, what is their operation, and the LP cutout, HP cutout, and differential loop bulb cutout, and all these will be discussed in another session. So be in touch, wait for the next video, and if you like the video, you can comment and subscribe the channel. Thank you.